And that's basically it about advanced object types. I recommend you to do a final exercise that actually wraps up everything we did today. The exercise is as follows. You start by repeating what we did with factors. So create a factor with 3 levels, still, medium, and sparkling. Just create any factor, any amount of the different instances as you want. It just should be a factor with these 3 levels. And then please compute the relative frequency for medium in your factor. We have already dealt with how to compute absolute frequencies. Here I'm asking you to go a little bit beyond that and to compute the relative frequency of one of the levels. Then next task is to create a data frame with 2 columns, one called NB containing the numbers 1 to 5 as double, and the other called car containing the numbers 6 to 10, not as double but as characters. So here you need to learn a little bit how you can transform the types of single columns in a data frame. Then next step, transform this data frame into a tibble. That should be easy. And then last point, extract the second column of this tibble such that you get a vector, not a tibble. So here we want to discuss quickly the one possible solution for the final exercise of the session on advanced object types. So the first task was to create a factor with the levels still, medium, and sparkling and arbitrary instances of the 3 levels. So whenever we want to create a factor, we use this function factor. And the first thing we need is to provide a vector that actually contains the element of the factor. So in our case, we want a vector that has 3 different elements, still, medium, and sparkling, with arbitrary number of instances of the 3 levels. So in my case here, I decided to use this function rep that you've encountered before to create a vector with 4 elements still, 6 times the element medium, and 3 times the element sparkling. If I create this, I already see here that the factor has been created as desired, and I might also give it a name here such that I can reuse it. So the next task was to get the relative frequencies for medium in this factor. We heard before that we can use the function table to get the absolute frequencies of the element of the factor. But here we want to have the relative frequencies. So here's a good idea to proceed stepwise. So first of all, we use table to get the absolute frequencies. And then to get the relative frequencies, we just need to divide every absolute frequency by the absolute number of elements of the factor. So we need here the number of elements, and we can use actually the same function that we would have used in the context of normal vector. That is the function length. So if we do that, we see an elements here is 13, and 13 is 6 plus 4 plus 3, so that is correct. And if we then get the relative frequencies, we then can make use of the concept of vectorization to just take the vector of absolute frequencies and divide it by the number of elements. And if we do so, we actually get the relevant frequencies if we had defined absolute frequencies above. Here, so very typical example of how you get this error, object abstracts not found. Did we misspell it? No, but we forgot to execute line number 7. If we do so, we now get here the relative frequencies. If we want to get rounded numbers, we can use the function round from R. Here is, we first provide the numbers to be rounded, the numbers of decimal places here too. Here we get a cleaner result and the relative frequencies of the three elements. So for medium, it's 0.46. Okay. Next part of the final exercise, we should create a data frame with 2 columns. Let's call it df final. One of the columns should call numbers. We can create this here, and it should contain the numbers 1 to 5 as double. We can use the function sequence 1.5. And the second should be the numbers 6 to 10 as character. Here we can use, again, the concept of vectorization. We first create the sequence from 6 to 10. If we did so, we would here get the data frame as expected. If we want to know about the types of the columns, we could use the function glimpse. We see, okay, they are both of type integer. The first should be double, however, so we can add here the asDouble function, and the second should be of type character, so we can use the asCharacter function here. If we do so, now we get the desired result. Next step, transform this data frame into a tibble. So we can here use from the tibble package. We can use the function asTibble. So we now here have our tibble. And then the final question was extract the second column of this tibble such that you have a vector. Well, vector is probably a little bit too general. What I wanted to say is that you have an underlying atomic vector. You can use the square brackets here, but remember, if you use only the single square bracket, you get a tibble here, because this only attracts the column. But if we use double square brackets, then we get the second column and get the atomic vector of the underlying column.